Hello everyone, welcome back to the channel. So in this session we are going to cover operating system process scheduling. This topic is very important for your college or university level examination, as well as if you all are preparing for any competitive exam, then this lecture will definitely help you. So we will start with process scheduling introduction, then different types and states of scheduling. So let's start the session. As you can see here, a process scheduling is nothing but it is the activity of the process manager that is used to handle the removal of running processes from the CPU and the selection of another process on the basis of a particular strategy. In simple terms, we can say that, let's take an example here. We have three processes P1, P2 and P3. All these three processes are waiting for resource R1. Let's say this resource is nothing but a CPU. Process P1 wants to execute itself by using CPU, but at the same time P2 and P3 wants the CPU, and these two processes are in waiting queue until process P1 releases the resource. That's what we have discussed here. Process scheduling is the activity of process manager. So all these three are the processes, and process manager is responsible for the management and allocation of the resources to these processes. Okay, so processes that handles the removal of running process. Let's say at point P1, at point 1, P1 is using the resource CPU. Okay, that means it is in the running state. It is the running state, running process at that particular time, and at the same time process P2 and P3 are the waiting processes that are waiting for P1 to release the resource so that these two remaining processes can capture that particular resource. Okay, so here we have some particular strategies that we will cover later in this video. Also, note one more definition here. Process scheduling is an important part of multi-programming operating system. Multi-programming operating system. As we have discussed, we have three processes waiting for same resource R1. So this is what? This is multi-programming, multi-processing operating system. So process scheduling is very important part in this type of operating system that we have already discussed in detail in some previous lectures. It is also the process of removing the running task from the process and selecting another task for processing, and it schedules a process into three different states. Okay, so here let's talk about different states of process scheduling. So we have three different states. First is ready state, another is waiting state, and third we have is running state. Let's take an example here. When process P1 is using resource CPU, then it is called the running process, or the process is in the running state. Process P2 and P3 are waiting for P1 to release that resource. That means process P2 and P3 are in waiting state. Ready state is nothing but it is a state where one of the process that is in waiting queue is getting ready to receive the resource. Okay, so all these three states are very important. Now let's just move to the categories. So here we have two types, two categories: preemptive scheduling and non-preemptive scheduling. Non-preemptive, you can remember it like non-stop. That will be very easier for you to remember the definition. Non-preemptive means non-stop. Okay, in non-preemptive, the resources cannot be taken from process until the process completes the execution. Let's say here we have process P1, P2 and P3. Process P1 wants a CPU just for 20 seconds. Process P2 wants CPU for 3 seconds and P3 wants CPU for 30 seconds. Okay, if we are using non-preemptive scheduling format, then if a process P1 is allocated to CPU, once a process is allocated to CPU, it can only release the CPU after it get executed completely. That is the non-preemptive scheduling, that is non-stop processing. Once the processing of any process is started, it will only stop जब वो कंप्लीट हो जाएगा 20 सेकेंड्स के बाद. बीच में after 10 seconds, after 20 seconds, we are not allowed to stop the processing. This is what non-preemptive scheduling. So note its definition. The resource cannot be taken back from a process until the process completes execution. The switching of resources occurs when this running process terminates and move to waiting state. Okay, in case of non-preemptive scheduling, there is no chance of any process to set back to from terminate state to the waiting state. Okay, and in case of preemptive scheduling, let's take an example here. Again, I'm taking three processes. Process P1 wants CPU for 10 seconds. Process P2 wants it for 3 seconds. And process P3 wants it for 1 second. In case of preemptive scheduling, the operating system allocates the resources to a process for a fixed amount of time. Okay, so let's say our process P1 wants CPU just for 10 seconds. But in case of preemptive scheduling, we always allocate some amount of time. Let's say I have taken it for 5 seconds. So if process P1 is using the CPU, if process P1 is using the CPU and it wants it for 10 seconds, but according to preemptive scheduling, after 5 seconds, we have to stop the processing of P1 and we should allocate the CPU to process P2 just for 3 seconds. This is what preemptive scheduling says. Okay, during resource allocation here, the process switches from running state to the ready state, from waiting to ready state, or from waiting to the ready state. Overall कहने का मतलब सिर्फ यही है कि इस केस में if processes are running, then we have to stop the processing and move that process to ready state, or either our process is in waiting state, we need to move it to the ready state. Okay, so this is the difference between preemptive and non-preemptive scheduling. I hope everything is clear. In next session we will cover preemptive and non-preemptive MCQ questions or numerical questions for your examination. Next, we have two states process model. Two-state process model. Here we have two states, running and not running. Running state means a new process enters into the system in running state after the creation. Let's say we have three processes and process P4 is entering into the system in running state after we have created the queue. Okay, and not running state means these are stored in a queue until their turn to get executed arrives, and each entry in the queue points to the particular process. Okay, so not running queue can be created by using linked lists. We have discussed linked lists in your data structure unit. We have completely done the data structure unit, right? So that's all for today. For tomorrow, we have scheduled an important topic, that is operating system scheduling algorithm. There we will cover 6 important algorithms. Okay, so first we'll start with the theory session, then I will share some numerical questions with smart tricks that will help you score good in your examination. All these types are very important and we will cover every point in detail. So thanks for watching this.